Hey everyone, and welcome to another edition of the Data Idols and Data Science Festival Summer School. I'm Jess, the Community Director and part of the team that helped put this summer school together. So I hope you're enjoying the sessions if you're watching them live, and if you're watching this recording, welcome back, and hopefully you're scanning through and seeing some other things that you're able to watch as well. In a minute, you will see a link in the chat that will be to our Slack channel. Feel free, if you have any issues, you can chat to us, or it's a great opportunity to network and chat with other attendees. And ask them questions as well during those sessions. So feel free to join that and you can follow along. So before we get started today, I just wanted to say a massive thank you to our summer school partners. I think as you've heard before, there's over 400 hours that have gone into creating this summer school, and we couldn't have done it without the support from every single one of these companies, giving up their time, producing content, and sharing their knowledge with all of us and our community as well. So a huge thank you to our partners. So today's session is with Raluca, who's done many sessions with us before and is a brilliant speaker, and she's from ETIQ, and she's going to be covering QA and model validation. So hopefully you enjoy and see you at an event soon. Thank you.
Hi, I'm Raluca, and today we'll be talking about QA and model validation stage in the model building process. Just a little bit about myself. I'm co-founder of ETIQ, a startup which builds solutions to the algorithmic bias problem. And our goal is, I guess, to identify and mitigate this problem. Yeah. So just going into, I guess, the meat of the presentation. This is a small anecdote. I've been in general data science space for about 10 years now, and I think maybe about 5 years ago or so, I was built. My team actually was, my team was building a model for a kind of retail, a big retailer, and what we were finding time again, like at the end of the model, at the end of training the model, it just seemed to be performing about 10 percentage points or higher than we thought a model like that should perform. And we literally went, like, this is a company that has a lot of data scientists and a lot of analysts around. So literally I went around the building like, does anyone know, like, why is this model so good? I mean, we're just struggling to figure it out, right? I mean, we're not quite believing in it, and we don't want to present it to our stakeholders like that. And in the end, we kind of realized that it was really a leakage issue, like about 5 days later, and like 10 people asked. It was a small code error that meant that some of the data from the target leaked into the feature data set. And of course, then the model was much better than it would have been in actuality. So yeah, I mean, it's one of those things really where I feel like the actual, the actual training of the model maybe takes like a day or two or whatever, picking up a nice algorithm, but then everything that comes before and everything that comes after is really the meat of the process. So just to contextualize, so yeah, this is why you should QA your model, and this is why you should, validate as much as possible. Beyond just the code, there's error that are specific to the kind of, shall we call it LML or whatever field, and really it's important to pay attention. Okay, just for context purposes, because I realize this is kind of a general audience. So if we quickly run through model building steps, then I can kind of maybe contextualize a little bit where this stage should appear. So this is just very simple, like a simplified version of this. But essentially, assuming you have some sort of, this is just an example, assuming you have some sort of data that's been collected, you'd maybe have some exploratory analysis and so forth. You know that your goal is, for instance, to predict likelihood of default, or whether you should hire person X, or whatever your goal is. So you know all of that, you have your data, you've talked to your stakeholders. And now you're starting, the actual process. So you're looking at your data, you're like seeing what's in there, what kind of correlations and so forth are at this stage. You're then starting to build some features. Maybe your model is customer level, you want to predict that, for each customer, like whether you should lend to them or whether you should acquire them or whatever it is you want to predict. So you're building this feature data set customer level, you're then, wonderfully training your model, great, you got a great model. And then afterwards, ideally before you put it in production, you should really check it to make sure that it kind of is not wrong, and the results you got on your test is like kind of something you can, if you obtain maybe, let's say 70%, 75%, which is quite high actually, depending on your problem area, but let's say you obtain 75% accuracy for a classification problem, then will you be able to sustain these output, this level of accuracy in production? So this is kind of the stage at which these checks should really happen. But once you productionize the model, so let's say, okay, you're happy with your model, you either pass it on to another team, or maybe if you're a small team, you do it yourself, put production yourself, then really that's not kind of the end of the journey. And there's also at this stage, this is when errors really come through. So there needs to be a good monitoring process in place to capture this. And I'll go into what kind of errors come through later, but you can imagine that, things change over time, and this usually impacts how great your model does. So this is just a simplified model, but model process, but to give you an example of something, shall we say, not necessarily nicer, but more applicable for some cases. And this talk is not going to go into kind of tooling and everything for this, but you could have something simple like this, or you could have something super complicated where you need orchestration tools like Kubeflow or something like that. You need maybe a CI/CD tool. You need a versioning tool like GitHub as well. So you need your model kind of gets, shall we say, I wouldn't say constantly trained, that's a bit much, but you are updating your model much more frequently than maybe in this instance. You're, monitoring for it, maybe you're reacting to like the errors much more quickly. So just be mindful, this is a simple version, this is a complicated version that oftentimes does happen in production. But regardless, the meat of the thing is about whether you use like super fancy tools or, just very basic ones. These errors can come up regardless. So this one we'll be talking about today, and going straight into the, so this is kind of what the main topic, but going straight into the kind of sources of error. I think this is the key bit, and kind of no tool can catch this for you, really. I think it's something you have to be mindful of, but there are packages out there that will help you either structure your kind of checking of your model, or actually provide you with pipelines that make the checking faster, so that you need to write the code yourself. Regardless. So in terms of the type of errors, so these are some of the key ones. I mean, there's more, you can go in depth, but for instance, what often tends to happen is that actually you're working on a sample that's not really representative of what's going to happen in production. So your model looks really good on paper, but in practice, it's quite bad. Like if you're building your target is very seasonal, right? So you're trying to predict something that is really, like change it. Like maybe you're trying to predict people are going to buy a certain product that they only use during the winter, or something like that. And then you're using data that you got from summer, then unlikely that's going to work out, even if maybe you find some people that bought that product in the summer. Or there could be certain things that are really impacted by the seasons, and it's not so immediately apparent, like the example I just gave. Another thing that happens, which is related, is that it's not just like that in a sense the problem is set up incorrectly, but the problem might be set up really well, and actually you've really looked at your data and everything, and it makes sense, like you maybe have a yearly time view and you're really kind of thought it through from that point of view. But you go into production and things change. I think with COVID, for instance, a lot of issues came about where models decayed very quickly, or the models were seeing data that they hadn't seen before. So the distributions of the data that they were scoring on was very different from the distribution of the data they were initially trained on. So like the maximum were super high, like they weren't finding the same minimums or whatever. So as a result, like the model was just not, it got confused, understandably, let's say. It stopped performing well. Or another thing that can happen here is that it's just not, the model is just not right anymore. So that's the model decay. So it's not, the data might stay the same, but the factors that led to an accurate prediction are no longer the same. So this is like obviously like a massive area. Another massive area is the bias topic, and I think this is has a slightly different angle. Obviously, this is kind of what we specialize in at ETIQ, but the idea here is more that one, in some sectors, you really have to be mindful, but I think overall you have to be mindful that your model shouldn't really be performing really well for one demographic and really poorly for another, because you inadvertently then will end up discriminating people, like especially like in things like financial services, justice, and so forth. That is quite bad, and I'll go into that example a bit later. Data leakage can be a problem. So that was about the anecdote at the beginning. I think, you say, why would you use, of course, you'd never use your target among your feature data set. But if you have like maybe 200 features you're starting with, maybe ending up with 20 even, or maybe 50, I mean, and they're all called differently, and you got that data, God knows from where. I mean, the reality is a little bit different from, I guess, the kind of at home plan. And some other sources of error are purely that if the implementation is wrong. So if you do pass on your model somewhere, or even if you build it yourself, it's different in production, because usually the data feeds tend to be different from what you build the model on, because there's a certain frequency to them and so forth. So errors happen. They're usually code errors, but there's ways to check for them regardless. Also the model itself might be problematic. So maybe you're really very focused on the accuracy, but actually the performance across different segments is not that good. It's just one segment kind of is overshadowing that. Or maybe like this, the overall robustness is actually not high. Maybe your model is overfitting and so forth, and maybe the way of testing is not quite right. Okay, so to get into like a specific error source, so we'll go through two main error sources today, and then I'll briefly touch on a third. So the first one is bias. I won't try to kind of dramatize the topic too much, but essentially, this happens all the time. Most time people don't necessarily, catch it or are not necessarily aware that it's happening, which is kind of the worst case scenario. But essentially in things like recruitment or financial services or justice even, it's when people are predicted to be in, a poor fit for the job, let's say, not really because of some inherent quality that they have or don't have, like in terms of skill set or whatever, but because of their certain demographic. And the models has only seen people from, let's say, a certain background before, and now it's seeing these people from a different background. It's like, well, it doesn't know. The model doesn't have a way of saying, well, this is a common sense, good feature to use. It makes sense that you should like kind of lend to people based on their income, but maybe it doesn't make as much sense that you should lend to them based on whether they shop with that merchant or not. So it's that kind of thing. The model is not going to be able to differentiate the way we would. And that's when this error comes up, really. Some ways to these are some ways to measure it. And I'll just quickly go through them, and then we'll just go through a very quick example. But essentially in the literature, so there are some measures of it, which are primarily around, if your model is at like 80% accuracy for male and like 60 for female. I mean, already within the nature of the model, you're struggling to be fair, let's say, right? So it's like you're building if you build a car and it works less well for like half of the population, or like you know, something like that, then you'd be like, this is not a good car. So that's kind of one area, and one area of measures, and this is basically equal opportunity, equal odds, and demographic parity are roughly from the area. So these are more group measures. And another way of measuring this is around, it's what's kind of called individual fairness, but there's a lot of other measures around as well. And it's this idea that, you know, the people should be treated the same. So if you have two people that have very similar characteristics, they just happen to differ based on gender, let's say, or some other demographic that you really should have nothing to do with whether they get along or not, then you shouldn't really, they should have the same outcomes. And this is something you should check for. I mean, you know, whether people check for that or not is like question mark, but you know, you should. But going into kind of more the sources of bias, and I'll just quickly go through this. So thinking about it from, I guess, what could cause this problem in your data. First of all, you could have maybe your sample size is kind of very skewed towards a demographic. That tends to happen a lot, because kind of usually the protected is by definition a minority demographic. So you generally don't have enough data, but you just need to be mindful of it and try to adjust for that and kind of, you know, just deal with it. Another issue that kind of appear, which is limited features, is that there are different drivers, different demographics that lead to the outcome. So, you know, the world is not the most fair place, and I guess the data reflects that. And it doesn't just reflect it in, you know, the sense that, you know, oh, some demographic is more risk averse than another or whatever, but it reflects in the sense that you might just not have enough information. Like there might be more randomness for one demographic versus another, right? So that's a slightly different point. Then there's a few other things that actually are not even necessarily observable from your data. So it's not something we're going to go into right now, because I think we're focused on a very specific topic, which you can actually see. But the fifth thing is around proxies, and that's something that people usually tend to understand quite quickly why it's wrong. I mean, let's say you don't want to you're not using the demographic specifically in your model. So then if there is something else that is kind of hugely correlated with it, then you probably shouldn't use that either. That's the rationale here, and you should find it. Again, you know, this is kind of easier said than done. If you have like a lot of features to start with, and the values of the features, maybe the categories kind of get lost in the transformation and so forth, it's actually very easy to have these things happen, much easier. So now going to an example. So I'll be using, there are a lot of packages around, and I'm not sure what will be distributed after this, but if we do distribute the notebooks or the slides, and I'll add in some more. One of my favorites is IBM Fairness 360. It's super comprehensive metric wise, but there are others like newer ones as well, like DICE, which deals with factuals. And they're good packages. You know, there's good packages in this area of algorithmic bias, but they're also sometimes not, you know, easy to use. So I'll give you the example using our package, but you know, as long as you check using something, that's kind of the key idea. So this is just you know, just a kind of run-of-the-mill model, nothing too fancy. So I'm just going to start running it. And this is a little bit how the data looks like. So yeah, I would so it does from the actual model, we'll take out things like gender. This is all based around gender, right? But race should be out as well, age should be out as well. But this is roughly, so it has very few features, and it's a very well-known and used data set in the field. Okay, now we just start kind of to train the model, right? So there's nothing crazy here. It's just for the purpose of the example. There's some transformations happen, I think, which maybe are not necessarily in the right spot, but we'll see what happens. There's some encoding happening again. There's some, because you won't be able to use the actual categorical variables, but that, again, this is just for example purpose. I think we actually took that from a Kaggle notebook. So our kind of goal is to use these packages and use, the example is how to find the error, not really how to build the best model. So yeah, so we start kind of spinning the train test and so forth, and we start training. And these are some initial results, which are actually, in my opinion, very high. But okay, it's not, it depends on the problem matter. Of course, this is a customer level data set that's using some very high level variables to predict income. So, I mean, the odds that you'll get it right with only those features are not, they're 89 is very high. And that to me suggests there might be an error, but let's keep going. So we're starting to evaluate kind of, from a fairness or bias point of view, is there an issue with this model? So the way we do it is that we first evaluate, because of this package, we kind of have to log in things in the package, right? So there's nothing terribly tricky about this. We just log some, the quote unquote protected. So in this case, we're just looking at gender. Usually you should look at everything you have available. Sometimes you don't actually have demographic data, but you should really, if you have age, ethnicity, whatever, like you should be mindful of it, because even if in certain cases you might be able to use it, like age, for instance, you really should know what you're doing with it. So yeah, going back to this, you're just logging the parameters. So you're looking at gender, you're saying the privileged, unprivileged, male, female. This is kind of the convention of the field to use these words, privileged, unprivileged. I mean, it can be the other way around in some cases, like around insurance, for instance, like especially when it comes to gender. I think that's up to the particular use case. But the point is that just one of them is kind of, we're looking out for it versus the other. And then you also have to give it the actual label, just so that it understands a little bit about what it's predicting. Okay, a few transforms. Okay, I need to actually run this, a few transforms. And then you log in the data set again. This is just part of the logging, the specific logging of the package. And you're giving it, let's say you're giving it some splits, or you can put the splits you already have in, and so forth. Great. And now you're deciding on the model. Again, I'll just skip through it quickly, because these are really things that you're just doing as that you kind of thought through already, and you're just doing it as part of the model build. And here you're starting to kind of ask it, okay, what kind of metrics do you want to look at? So obviously, like, accuracy is a big one. And then, because let's say we just heard that equal opportunity is like an indicator there might be a bias problem, then we plug that in. Equal opportunity, by the way, is it just looks at whether true positive rates differ for the demographic. So there's nothing fancy here, but it's something that people don't usually look at enough, and they should be, because that's a good way to see if your model is maybe underperforming. Okay, again, you just run this, the initial pipeline that you have, and then you start looking at, sorry, I moved a little bit. You start inputting in the device pipeline, and you start running it. So in this particular case, we're looking at trying to identify the bias sources. So I don't know if you remember, but if we look at the sources here, I guess ideally what we want to get is, okay, in this pipeline that I just had, so I have my data set, my model, my training test split, whatever it is I have, I'm predicting, my protect, and so forth. So given this pipeline, am I finding some of these issues? Now, we know these two we cannot observe based on that information only, and they require more work. But the first two and the last one, are we able to find that in the, in this pipeline? I mean, ideally not, but it's something you should check for. So, okay, first, does it give you a different metric? The equal opportunity one, is it different for in this case, male and female? And yeah, I mean, it's an example that we set up this way, so don't be too surprised. It does. There's a difference, but the idea is that, okay, this is like your first hint that maybe something is not quite right. I mean, the difference is not huge for the kind of things that actually oddly can go through, but still, I mean, we're looking at 12% difference. I mean, it's not, could be worse, but it's high. So you're missing a lot more women than you're missing men, because your model seems to be optimized for them. And then in terms of the actual issues, let's see if you have some of the other issues that we've, like if we go to the source of what causes issues, what can we find? Now, this particular function kind of tries to find the issue by segment, because the idea is that you might have, your correlations might look good in aggregate, so nothing is really kind of standing out. But you could just look at correlations as well. So the idea is that while in some cases on the aggregate, if you look at the correlation between some features and your, let's say gender, or whatever your protected demographic is, you won't really see much correlation. Actually, they look quite good. So you're kind of lured into this false sense of security. But let's say here, actually, while those look quite good, you still have some differences when, the model picks up. So the question is kind of why? So sometimes it's a good practice to look not just like overall, okay, well, is the size of my sample different for the different demographics or not, but also like more segment level. So this is an example here where it's kind of finding some issues with the sample, for instance, in some segments. It's finding some correlation issues, and it's finding a big proxy in what seems to be a lot of segments. And I think if we go back to data and actually look at it this time, we see that the relationship actually, where is it? Yeah. So, I mean, it's pretty obvious that this is a proxy if we actually look at the values, right? But, by the time you get to the actual training stage, probably transform this so heavily, you don't actually know what the values are. So that's why it's important to actually check and make sure, especially if you have more features, that these things don't come up. So yeah. Moving on to the other issue we're gonna do an example on. It's data leakage. So again, one of those things, obviously, you're never gonna run into this issue because you've set up everything perfectly, but in real life, this is kind of what ends up happening. You will run into this issue. So these are, so the issue, like the concept is not like something terribly complex. It's just this idea that you shouldn't really be using information to predict something that you don't have at the stage of prediction, or that you don't have. So it's almost like, oh, I'm trying to predict, shall we say, I don't want to give away the example, but I'm trying to predict yearly salary, and I have like monthly salary. That's a pretty terrible one, like somehow monthly salary got in there, and it's actually just a description of my target, and I've put in the feature data set, I have the best model ever, but really it's not that good. So yeah, there's a few different kinds of leakage. So one type is around the fact that, like I said before, like the target somehow seeps into the feature data set. It tends to happen more than you think. It might not seep in completely, so maybe just does it for a segment or so, and that's where it's harder to pick up. But it does. So this is one element, but it's not, sometimes it might not be the features, the target themselves leaking in, but it's a demographic or a feature you don't want to be including in your model for whatever reason that seeps in. And that's the overall overlap with the bias, but it's something you also should check for. A different kind of leakage problem is around the kind of row level leakage, let's call it that. I don't know if that's the right way to put it, but it gives you some idea of what it is. And for instance, if somehow your test sample got contaminated from your training sample, and you have literally, like, this actually does happen. Like, we talk about it as if it's like, wow, never happened, but it happens very frequently, especially if you use some more sophisticated stuff. But if some rows from your training sample are somehow included in your test sample, of course, your model will look great on paper because it already saw those people, or it already knows what those people will do. Like, it's not like your test sample is not really testing for much, like it's, you already know the information in there. So that's one example. Another example that's kind of similar is if, for instance, you're trying to predict things around time, right? So you're trying to predict what's going to happen next quarter using data from this quarter. But let's say maybe you went back like a year or so because you wanted to get a test sample that it gives you the equivalent situation that you're trying to set up. And actually, when you did that, you accidentally got some of the things that happen in the quarter that you're training on ended up actually appearing in the quarter that you're testing on, or vice versa, right? So you didn't stick to this kind of time differentiation properly, and then obviously, like, your model will look great. It won't necessarily be great, and also it'll probably, the issue with it is not just that the model looks better than it will be in production, but the issue is that you wouldn't have optimized your model properly, so then it would be a missed opportunity, right? So maybe had you done it properly, it would be feature 1 that would have been the most significant. But because you did it poorly, it ended up being feature 10, and actually the actual predictions will be worse than they would have had you not had this error, right? And another kind of issue here that's a little bit, what's the word, subtle as well. And again, I think this is one that people actually, you can see how it's a problem, and people kind of still debate, should they do it, shouldn't they do it, is when your transformations include test data. So let's say you're normalizing a feature, and then you're normalizing on your whole data set, and afterwards you're splitting in. The impact is smaller maybe in other cases, but you're still giving your model information it shouldn't have access to. Like, let's say if, maybe, it shouldn't have access to, maybe your the distribution, your test sample for one feature is slightly different, you know, maybe not by much, right? It's still like a randomly chosen, let's say, sample, but it's a little bit different. And that means that your model had access to knowledge about that distribution that it really shouldn't have. So yeah, so the example will be quite quick. And again, I think while with bias personas, I mean, there are, I don't feel like there's, you know, too many libraries, but there are a few more. I think with actually leakage and some of the other issues, I am struggling to find things that don't need to be coded from scratch a little bit. So that's why I'll be using our functions. But again, if you find something, I mean, this is just one way to do it, really. So great. So again, same example, except I changed the data a little bit now. So we changed the data a little bit, including a feature that maybe we shouldn't have. And now we're getting, wow, 100% accuracy. This is like really the first sign that this is like a terrible model, right? I mean, maybe I should have changed the data set a little bit differently so that it got like 90%, 95 or something, but still like, you should have in your mind a benchmark for your model. And the benchmark usually is set either by previous models or in your business or just generally by the literature. Now, if your model is really much better than that benchmark, then something's probably wrong. I think that's a good way really to be worried about it. You know, if it's a little bit better, that's good. Conversely, you know, your model could be right on the benchmark and still have some issues in it. So that's not, you know, the other way it doesn't work, but it's a good indicator there might be some issues. So in terms of the leakage, again, you know, we'll just go to the same process. I won't really kind of dwell on it too much. Realistically, whatever you use, whether it's a package or something else, you will have to either input in the functions or log somehow if it's a pipeline. So yeah, so we've run in this case a leakage pipeline around the features. And this is some of the issues he's found. Yeah, I mean, I'm not terribly creative when it comes to these things, but it found that essentially monthly salary has like about 100% essentially correlation with the target. It's a target leakage issue. Ignore the other bits. And so, I mean, you know, the surprise I put in was really just monthly salary. This monthly salary feature that is really, if you're predicting income, you know, yearly income, and then you're adding a feature like that in your feature data set, then that's a problem. And it's just for example purposes. In real life, I think the examples wouldn't be so obvious. Otherwise, you wouldn't be missing them. You know, so that's the thing. Or actually, the example could be just as obvious, but maybe this feature is called feature 0.011 or something, you know, and then it's there, you just don't remember what it is. Maybe you inherited from somewhere else, you don't know what it is, and so forth. While we say, you know, we always say, oh, you need to do your exploratory data analysis properly and make sure you you really understand your data before you do the model. In reality, the more data, the less like, you know, like it's highly likely that you might miss out on something, which is why you should also check at the end. Okay, great. I'm gonna move to the next bit, which is just a little bit more on data drift. I do not have an example. I'll confess, I do not have an example prepared on this because it's just a little bit harder to kind of, well, it's not harder, but it's because it's a problem that really appears in production predominantly. It's harder to give an example that is kind of a real life example, whereas the leakage and the bias really, they do appear at during the build. So in a QA setup, it'd be quite, I don't want to say easy, but it'd be easier to pick them up. Things like drifts, it's very hard pre-production to forecast that you're going to have drift. You know, like, I mean, there's some instances where, like I mentioned, the drifting is inherent to the problem, and you're using the wrong data, really, if you have strong seasonality or whatever. But in most cases, actually, it's something you'll find out at the time. And there's kind of two separate things here that you need to watch out. The first is if the distribution of the data that you trained on changes in production. So that's like, the name is data drift, but essentially it could be, you know, it's not just the feature data set might change, but it could be that the target might change as well. And, you know, all of a sudden, let's say maybe COVID again, but let's say there's a recession and people are just like more likely to default on their loans, right? So the distribution of the target will change quite a bit. Or let's say, this is not so much like, you know, driven by outside circumstances, but driven by maybe what the company is doing. But let's say maybe initially the company was, you know, targeting a certain part of the country, and now they're expanded to the whole country. So of course you're getting people through that look a little bit differently, or maybe they've expanded the age range, or maybe they've you know, they're not targeting a different product as well. So of course the data will end up looking differently, because really you're trying to use a model that was designed for different purpose, for this purpose. But we do see it happen quite a bit, because especially when it comes to things like marketing, you know, they're quite, they change quite frequently. And so there's the drift topic, and kind of related to it, and I think kind of in this often kind of overlapping, is the model decay area, and that's more is genuinely the relationship between the features and target change. So what used to be predictive no longer is, and maybe other factors are predictive. And you're essentially, when you're scoring someone, you know, let's say maybe your most significant feature for a certain kind of customer is number of years in a job, and you know, you're scoring them based on that, right? And then something about the world changes, or something about your data and just generally what you get in changes, and now that's not really such a key factor, and actually it's more about their qualifications, let's say. So you're using a model that really is not fit for purpose anymore. There's a lot of debates about when you should be refreshing the model. I'd say it isn't the more frequent the better, because in a sense you also have to give it time to kind of do its, you know, to score. Some people predict some outcomes and then see if it's wrong or not, because if you have, you know, it just scored 5 people and then you're already concluded it's wrong, then that's not robust either, right? So you have to give it some time, but at the same time, I think the idea is that it's better to be cautious on just monitoring it all the time, let's say, or like as frequently as possible, especially if you have a nice pipeline setup, you know, with the right orchestration and everything. Then, you know, monitoring is really the way to go, and then you should maybe review it like as you get some volumes in to justify that you have some robust results for your review. So yeah, this is pretty much the end of this presentation, but hopefully enjoyed it, and we'll try to make some notebooks and examples available from the talk.